Hello, I'm Yash from N Division and this is our course project for engineering exploration on toroidal winding machine. We are a team of 4 members and my teammates are Daneshwari, Ramakrishna and Sanket. We have been working on this project under the guidance of Padmaja Madam. We have included 5 steps of design process in our project which can be seen in the further slides. Problem definition. Problem definition consists of objectives, functions and constraints. The machine should be semi-automatic, portable and easy to use. The main objective is to make the winding easier and faster. Thin copper wire should be used for winding purpose. The machine should make a maximum of 1000 turns and it should weigh less than 4 kgs. We should be able to build the machine within a budget of rupees 3000 and it should be of the compact size of 2 by 2 meters. The primary function of the machine is to wind wire based on the inputted number of turns by the user. It should be very precise in doing so. It should be able to display the number of turns on a display and also sense the spool and the wire. As you can see in the image, we have divided our need statement into 3 main subsystems and they are handling the wire, handling the spool and indications. The functions under handling the wire are to sense the wire, to store the wire, to wound the wire around the spool and to terminate the rotation of the wire. The functions under handling the spool are to sense the spool, to hold the spool and rotate the spool and to dispense the winded spool. The functions under indications are to input the number of turns to be made, display the number of turns, detecting the winded spool and the signaling the completion of the winding process. As you can see in the function clustering, we have clustered all the functions of a particular subsystem. The blue boxes are the subsystems and the green boxes are for the functions. Subsystems identified. We have identified 3 main subsystems and they are handling the wire, handling the spool and indications. We had 4 main designs to go forward with. As you can see in the design number 1, it is a simple toroidal type of winding in which the rotation is along the x-axis, as you can see in this part. In design number 2, it is a simple type of winding in which it consists of a DC motor and it rotates and makes the winding. In design number 3, it is also a simple type of winding in which the rotation is uniform along the x and y axis. In design number 4, as you can see, it is a toroidal type of winding in which you can see the core over here and the outer ring basically is over here, and as the motor rotates and this pulley rotates, it makes winding on this toroidal core. We chose the design number 4 based on the pug chart that we had created in the early stage. So now let's look into our virtual implementation part. So first is the 3D model of the entire system. As you can see in this image, this is the assembly of the final project. So let me show it to you in the Inventor app. As you can see, this is the final assembly and these are the rest of the parts. So let me open this up. As you can see, this is the final assembly and the red color part is the frame, the green color part is the outer ring which rotates along with the blue color bobbins, and the orange color core which you can see over here is the toroidal core, and this is the motor. Circuit diagram of the entire system. As you can see in this image, it is a simple circuit which consists of a DC motor and Arduino Mega. The DC motor rotates according to the number inputted by the user and it makes those number of precise rotations. Flowchart model of the entire system. As you can see in this image, Once we turn on the button, the Arduino gets activated and the motor is switched on, and the user is made to input a number, and based on that inputted number it decides whether to terminate if it is greater than 100 or to continue. Once it is less than 100, the DC motor starts to rotate and the outer ring starts to rotate and the winding of the copper wire starts. Winding continues till the required number of the turns are done. Button is turned off and Arduino inactivates and DC motor turns off. This is the bill of materials required for our project. So I would like to highlight some of the important parts required, that is the DC motor of 60 rpm, one quantity, and then the main thing is the microcontroller, that is Arduino Mega, and then we need a DC motor relay, that is 5 volt 2 channel, and the small bobbins of 6 unit, which makes the winding process. And then we have the spool support, that is the frame, and then these are the battery display, the outer ring, and some of the resistors. Motor sizing and battery sizing of the entire system for our course project. So let us first look into battery sizing. We know that the maximum current drawn by the DC motor is 300 milliamps, and we also know that the number of DC motors that we are going to use for our project is 1, and running time is 3 hours maximum. So from this, if we multiply all the three quantities, we get the capacity, and that accounts to 900 milliamp hour. So now let's look into the motor sizing. So the mass of the spool was found to be approximately 100 grams, and thus the force was calculated using the formula m into g. The diameter of the spool was calculated, and then the radius, and then the torque by the formula F into R. The torque was multiplied by a factor of 1.5, that is factor of safety, and thus the required RPM of the DC motor was found to be 60 RPM. Functional specifications of the entire system. We have over here 4 functions and their specifications. So the first one is accepting user input, and the specification: the machine uses buttons and takes the maximum of 2-digit number as input. Rotation and winding. Stepper motor is used for rotation, making complete 360-degree rotation of the spool of diameter, outer diameter 8 mm and inner diameter 4 mm, which thereby makes winding on the toroidal core. Holding. The toroidal core of diameter, outer diameter 12.7 mm, inner diameter 7.7 mm, and thickness of about 4.8 mm should be held in place horizontally until the winding process is completed. Lastly, indications. The machine should display a message "stopped" on the screen regarding the termination of the winding process. So now let's look into the modeling and simulation part. So first let us see the model, the 3D model. So this is our 3D model. This is the final assembly in the Autodesk Inventor 2019 app. So let me give you a brief introduction about what are the parts. So the red color part is the frame for the support, and this is the DC motor. These blue color are the bobbins, and this is the outer ring which rotates along with these blue color bobbins, and this orange color core is the toroidal core, which basically is to be winded with a copper wire. As you can see over here, there is a copper wire at this point. This is the copper wire, and this goes inside this and makes rotations around this toroidal core. So now let us look about how the model actually works. So this is the Tinkercad application. So this is the simple circuit which consists of a DC motor, and which basically is attached to the first bobbin. As you can see here, this blue bobbin is attached to a DC motor, and the user is made to input a number, and based on that The DC motor makes so many number of revolutions, considering that the DC motor is of 60 rpm. So this is the code you can see over here, and let's just start the simulation. So if I input a number as 10, it should make 10 precise revolutions. So as you can see, it has started rotation, and it will rotate for about 10 seconds because the motor is of 60 rpm. So this is it for the simulation part. Thank you. So let's look into the softwares that we have used for this project. So we have used Tinkercad for simulation of the circuit model. We have used Autodesk Inventor 2019 version for the 3D model of the parts and the assembly of the entire system. Circuit.io for the circuit design. GitHub updation. We have uploaded all the necessary documents that is required for our course project. So this is our GitHub page where we can see all the updated documents for our course project, that is toroidal winding machine. So this is the home, and then we have gathering pertinent information, and then we have problem definition, conceptual design and product architecture, virtual implementation, which consists of 4 parts, that is 3D modeling, circuit diagram, flow chart, and bill of materials. And then we have function specifications and interface performance specifications, and task 2, that is code for our circuit diagram.